Here we go. We're starting. Are you ready, Abraham? Okay, measures of a variation used by statisticians to describe how the data in a data set are spread out. Okay, range of a set of data. This we all know is the difference between the greatest and least variable and values. The interquartile range. Now remember, we've had range before. It's the difference between the greatest and least. This is the difference between the third and first quartiles. And remember, we had quartiles on our box and whisker plot, right? So it's if you take the third quartile minus the first quartile, that's called your interquartile range. Quartile 3 minus quartile 1. Okay. So, example 1. 13 men qualify for the 2018 U.S. men's alpine ski team. Find the range and the interquartile of their ages at the time of qualification. So on here, what you would do, you would look for the highest age. The highest age is 91 and the lowest is 21. So the range is 29 minus 21, which is 8. To find the interquartile range, we have to arrange from the smallest to largest because we have to find the quartile 1 and quartile 2, or quartile 3, which we did in the box and whisker plot. So let's go through and rearrange them so we have 21, 22, 23, 23, 23, 25, 25, 26, 26, 27.
There's only 2 23s.
Did I do too many?
We did 3, but there's only 2.
Okay. I hope that doesn't mess up my data. 28, 28, and 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, I think there was supposed to be another one. So, first of all, my median, how do I find my median? It would be in between the 1, 2, 3, 4, 5, 6. Now that I did this, it makes it seem off balance. It would be 25.5, right? I think we were supposed to have another 23 in there. Oh, well. So the median is 25.5. Okay? So this is quartile 2 also. So now I look at what your quartile 1 would be, and quartile 1 would be at 23, right? And here it would be 28. I guess it still works out fine.
Isn't it 27.5?
No, because this is the one in the middle. You have 5 values here. Okay? So now what you're going to do is the interquartile range would just be 28 minus 23, which is 5. Okay? It's just kind of common sense, isn't it? Good. After you know what a quartile is. Okay. Standard deviation, a measure to show of how each value in a set deviates from the mean. Now the mean is another word for what? Average. And also the notation is X with a bar above it in statistics. That you'll see also on your calculator, it'll be referring to that, X with a bar over it. The symbol for variation, standard whoa, should be standard deviation. Sorry. Is S, or it's this. It's a little Greek symbol that looks like that. Okay? So on here, this is the process of going through and finding standard deviation. You find the mean of all the data, then the difference between the value and each mean. You square the difference, and you square the mean of, or you find the average of the mean of these squares. I'll explain this. And this is the variance. And the variance is also another statistical measure, and it is shown by S squared. And you take the square root of that, and that is the standard deviation. And we got it right there. Okay? So, on here we're going to do a problem. Find the mean and the standard deviation for all of these numbers. First of all, to find the mean, and the mean, I'm going to just show you, it's like this. You add them all up, and you're going to have to know how to do this, even though your calculator does it automatically for you. But on a test, you will have to show me the steps. You will add them together, divide by 6, and you get 14. That is down here. I just wrote down here, and this should be deviation again, because I just copied and pasted. Down here are the steps. So we found the mean. Now we find the difference between each value and the mean. So what you do is you take each value, 17 minus 14, and you square it. That's step 9 there, which is 3 squared, which is 9. I take 12 minus 14, and you get negative 2 squared, which is 4. You have 6 minus 14 squared, which is negative 8 squared, which is 64. So what are we busy doing? Okay, just drop it in there. Okay, and you would have 8 squared, which is 64. You have 13 minus 14 squared. You'd have negative 1 squared, which is 1. And you'd have 14 minus 14 squared, which is 0 squared, which is 0. So, what we've done, we found the mean. We found the difference between each value and the mean. We squared each difference. Now we find the average of these means. So I'm adding up all of these. 9 plus 4 plus 64 plus 64 plus 1 plus 0, and I divide it by 6. And you will get 23.67. This is your variance. When I take the square root of the variance, you get 4.87, and this is your standard deviation. And that is all there is to it. The smaller the number is in standard deviation, that means that the numbers, the data numbers, cluster closer to the mean. The larger the standard deviation, we'll be studying that when we study the bell curve, the farther out the numbers are spread, the data. Okay, so this is pretty normal. I mean, this is pretty close in there. So if I want to now determine the whole number of standard deviations, this should be plural. And I'll show you what that means. The mean price, so we're already given that the mean is 6.57. My standard deviation is 2.01. I want to know how many standard deviations it is from the mean. So if you go, and I'm going to just do this, something very simple for you to understand. If this is 2, 4, 6, 8, 10, I don't know why I did this, 12, 14, 16. Okay. And ignore that one little line that I put there. Okay, I'm going to put the numbers. These are the numbers that we're putting in there. So $6, I'm going to just put an X above it. 7.2 would go along here. 10 would be here. 8.8 would be about here. 4, 6.5, 9, 4.9, 5, and 4.3. Okay, so my standard my mean is 6. So if this is 7, here is my, it's about right here. I'm going to draw a line here. This is my mean. And it gave us that is 6.57. My standard deviation is 2.01. So that is to the right and to the left. If I add 6.57 plus 2.01, I get 8.57. This would be my first standard deviation. Whoops, it would go about right here. This would be the first standard deviation. It's kind of just logical. If I subtract it on the other side, you will get 4.57. That would be about right here. This is your mean. Right here at 4.57, this is one standard deviation to the left, so it's a -1, they call it. It's below the mean. This one is 8.57, and that's a +1 standard deviation because it's above the mean. So now if I want 2 standard deviations, what do you think you do? You take 6.57 and you add 2 of the 2.01s. So it's 6.57 plus 4.02. You get 8.58. Shh. No, I get 10.58. Bad girl. 59. I didn't look at the right one. So you have this. And you get a stop. Why do I get a stop here? Because there's no other data's points above it. So it's 2 standard deviations above, right? And let's see if I would subtract it. If I would take 6.57 minus 2 times 2.01, to me this is kind of logical if you let it happen in your brain. So this would be 2.55, which is minus 2 standard deviations below, and that would be around about right here. Don't all the data fall in between that? There's nothing beyond that. So what your answer is, this says determine the whole number of standard deviations where this data falls. And it gave you the mean, or it gave you, the mean, and it gave you what the length of each standard deviation is. And so my answer would be it falls between 2 standard deviations of the mean. It goes 2 to the left and 2 to the right, 2 above and 2 below.
So that's the whole number of standard
That's a whole number. You can't say it says 2.5. You want a whole number. Now, if I would have had some other data points over here, it might have gone 3 above and 2 below.
Yes, so for your,
But then your mean would have probably been a little bit, yes, what?
your answer would just keep C.
Right, but I want you to understand what you're finding. It falls between, it's really 4 total standard deviations, right?
Yes.
But it's asking you how many does it fall from the mean. So it's 2 above and 2 below. Okay? So let me, yeah, that's it.